Generics. In this chapter, we'll talk about generic methods that perform identical tasks on arguments of different data types. And we see how you can create a generic static class that can be used to store objects of different types. Understand how to overload generic methods with non-generic methods or with other generic methods. Understand the kind of constraints that can be applied to a type parameter. Apply multiple constraints to type parameter. Generic methods enables you to specify with a single method declaration a set of related methods. Generic classes enables you to specify with a single class declaration a set of related classes. Similarly, generic interface enables you to specify with a single interface declaration a set of related interfaces. Generic provide compile time type safety. The purpose of generic class generic method is we want to save time. We create code once and we hope the code could be used for different data types. That's the purpose of generic. And many times in different situations, we don't know what kind of data that we can get in our application. And we hope that there's a program that can provide a interface. We call it as a generic that accept different type of data type, different kind of data type. That way we don't need to create code for each data type. We just create code once and we tell that this code works on different data type, especially the parameters passed to the constructor of a class or the methods of a class or methods. That means we don't need to specify it's an integer or it's a double or it's a string. We say whatever value passed to the methods or passed to the constructor of a class, then the code will work for any type. That's the purpose of generic. Save time and create short code. We can write a generic method for sorting an array of objects, then invoke the generic methods separately with an integer array or double array, a string array, and so on. To sort each different type of array, the compiler performs type checking to ensure that the array passed to the sorting method contains only elements of correct type. We can write a single generic stack class. That's what we're going to do later in our example, that manipulates a stack of objects, then instantiate a stack objects for stack of ints, stack of doubles, stack of string, and so on. The compiler performs type checking to ensure that the stack stores only elements to the correct type. Now let's look at this example. In this example, there are integer array, double array, and a character array. And what we do is we have methods. This method display array with integer array parameter, and inside there's a for loop that goes through the array item and display it. This is for integer, and the same thing for this is they all called display array. This is called operator method overloading. And the only difference is the signature. This parameter is integer array, and the parameter is a double array, and this parameter is a character array. But they all have the same name: display array, and display array. If you look at the code inside, they're all similar. They all have a for loop to cycle through the array and show the print out the array item. This is the same thing. And same thing. Just like we're repeating the same code for integer, for double, for character array. But there are different types, then we have to do this using operator overloading. So when we run the program, here's the result. Everything's displayed right here. There's one problem about this. We're repeating the code over and over again. We only have 3 arrays here. We have different, maybe 7 different data types array. Then we're gonna create 7 methods display array. Means we're gonna overload display array 7 times. I mean, with the same code inside. So we say, we hope there's a better way to handle this. We only write code once, create one method, and it wanted to work with any type of the data type array. And that's the idea of generic methods. Now let's look at the next example. And this is another example. In this example, these parts are same as the previous code, and this part are the same as well. And now in this code here, we only have one method. This is the only method here. Instead of having 3 versions of a display array, this time we only have 1 version of display array. But look at the code here carefully. Notice here, this is the brackets with T, and inside there's a T, square brackets, and input array. This is called type parameters. Type parameter. And we use this to tell that this is a generic method with generic type. And this tells that the brackets, the square brackets here, is an array of any type. Array of any type, any data type. And this is the array name. T here stands for any data type. Actually, T is the placeholder. It is the placeholder. All generic methods declaration have a type parameter list, like this, with with brackets. And we put this declaration after the array name. This is the array name, and then we have type parameter list, and then the type placeholder. Each type parameter list contains 1 or more type parameters separated by a comma. But in our example here, we only have 1 type parameter, so there's no comma. We only have 1, and that's the type passed here as a placeholder. A type parameter is an identifier that's used in place of actual type names. The type parameter can be used to declare the return type, the parameter types, and the local variable types in generic method declaration. The type parameter act as a placeholder for type arguments that represent the type of the data that will be passed to the generic method. And in our book, we have this text here. A generic method body is declared like that of any kind of methods. Note that the type parameter names throughout the method declaration must match those declared in the type parameter list. So let's look at our code here. This is the type parameter list. Any type. And in the parentheses here tells the parameter is array type, and there's a for loop. In the for loop, we say T, which is the type parameter type element in array. Then we want to show the content of each element. And after this generic method is declared, then we can pass any type of array here. And all we do is we call declare array, declare array, declare array with integer, with double, with char array. And when I run it, the result is the same. The result is the same. And from this example, you can tell that with generic method, we save a lot of time. We only need 1 version of this method, and we can pass any type to the method. It could be any type. Any type. It doesn't. Could be integer, could be string, could be double, could be single, could be byte, could be short byte, could be long byte, and so on. and could be an object of any class. Next, let's talk about type constraints. There's a library class called iComparable interface. It's from system namespace. iComparable interface object can be used with sorting and searching methods of classes in the system collection generic namespace. The types that implement iComparable interface must declare a compare_to method for the comparing objects. Type constraint. Type constraint restricts the type of argument supplied to a particular type parameter. Now let's look at this example. In this example, using console writeline to show these numbers and return the maximum number. Well, of course, it should be 5. And then same thing for these numbers and maximum. And then for the string and return the maximum. Notice here there are different types. This is the integer, this is the double, this is the string. And we're all calling maximum, means pass all of these to method maximum. It returns the biggest number. And here's the method maximum. You can see this is of course a generic method. It's generic method. And notice here this generic method has a return type t, and this is the parameter list. With the type parameter added here, we know this is the generic class, and inside there are 3 parameters, and the type is t, which is the placeholder for the type parameter. So it takes 3 parameters, any type. Notice here there's a where keyword. We call this as the constraint. And this method implements iComparable interface. iComparable interface has a method called compare_to. Here we use the where clause to add a type constraint. Where clauses here specifies the type constraint for type parameter t. In this case, the clause where t : iComparable indicates that this method requires the type argument to implement interface iComparable t. If no type constraint is specified, the default type constraint is object. Here, we tell that this method maximum must implement this interface method. In this interface, there's a method called compare_to, and that's why we add a method constraint here, called the type constraint, because we want to use compare_to from iComparable. So we must give and since we added a type constraint using where clause, then we must implement the code for compare_to, which is from iComparable. And if I put mouse over, it says iComparable can define a generalized comparison method that a value or class implements to create a type-specific comparison method for ordering instance. Now let's look at the code inside here. And this is the x, which is from here. We pass it to max. The max is type of t, and whatever type you pass to the method, then that's the type applied here. And then we have a if statement here. Say if y compared to is the method from iComparable, it compares the current object with another object of the same type. So the current object here is y, and the value to be compared is max. If compare to max means if y is bigger than max, then put the value of y into max. And same thing for compare to z. If z is bigger than max, then put a z into the max. And finally, return the biggest number, max, because the return type here is t. And that's pretty much this method does. After this is done, we just call integer, double, and string. So when I run the program, it tells me that the biggest one is 5, 8, 8, and pair. When it compared string, it compared the value of character P, A, O. And so P is bigger than A, and P is bigger than O. If the first letter is bigger than any other, the first letter of each word, then it stops, and that's the biggest letter. So that's why biggest one, maximum one is P, pair. And in this case here, this is the generic method, and this generic method can be overloaded. If we do overload this generic method, means we have several versions of maximum, then each overloaded method must have a unique signature to tell which one's which one. This is called a signature. We have 3 parameters here. It could be 2, could be 1 for the other versions of maximum. A class may provide 2 or more generic methods with the same name but different method parameters, signatures. A generic method can be overloaded by non-generic methods with the same method name. When the compiler encounters a method call, it searches for the method declaration that best matches the method name and the argument types specified in the call.